So I wanted to start off the video today with a little story on why somebody might want in-cab winch controls. A couple of years ago, I was down in Arkansas doing a trail called the High Watermark Trail. There's a ton of water crossings. The whole thing starts off with fording the Buffalo River, which is like a popular canoeing river. So it's like from the second your tires hit the trail, like you know you're in for quite an adventure. So I got to camp the first night and realized that I had forgotten a flashlight of all things. And then a little bit later I realized I had forgotten a water bottle. It was pretty chaotic getting out there for a few reasons, but I knew I was going to have to make the best of it. The next morning I woke up, there was like a beautiful waterfall right near camp. Hit the trail for a little bit. A little ways into my morning, I came to two enormous bog holes. The one on the right was extremely long. It was like 100 yards long. And then the one on the left was much shorter. So I decided that I was going to take the one on the left. And it was still freezing out. I remember there being ice on top of the bog hole. And just kind of easing my forerunner in, and the ground just kept slipping and slipping away from me. So I quickly realized and shifted into reverse, and nothing happened. Couldn't go forward, couldn't go backward. Shortly realized that water was coming into the cab. I could see it just slowly bubbling in. In fact, you can still see in the forerunner, there's a line there from that muddy water in that bog hole, and I kind of keep it around as a little warning to myself to not go in too deep. So I forgot my flashlight, forgot my water bottle. Luckily, of all things, I remembered to toss in my winch controller, ran my line out to a tree in front of me, pulled myself out. It got me thinking and made me come up with 3 reasons that I would want in-cab controls. First one is that it's foolproof. You can't accidentally leave your controller at home. Somebody else that's driving your car won't take it out and leave it somewhere. It's just always there, part of the vehicle. The second part, kind of related to that, is that you can't lose it. As I was hopping in and out of the truck as it's sinking in this bog hole, I was realizing, like, if I dropped this winch controller into this bog hole, like, it's just a bottomless pit. You're looking at 4 feet of just muddy water. There's no way you're going to be able to fish it out of there and find it if it sinks to the bottom. Same thing with just like setting it down on the side of the track. Like, who knows how long it's going to take before you realize that you've left your winch controller behind. The third one is kind of just tidiness. Like, I keep my winch controller in my door pocket. If I didn't have it there, then I could put something else there. And I keep my wired one in the trunk, but it's just one less wire flopping around, one less controller. I like to keep things tidy. What can I say? And then the last one is specific to me. This is the bonus one, and that's the nerd factor. Can it be done? I've heard of other people doing it, so a while back I ordered a switch and started looking into doing this. And I measured the signals with a multimeter on my Warn Evo 10S, and I was getting really weird voltage readings, and like voltage is ramping, and just didn't make a whole lot of sense. So I think Warn's doing something unique with their controller, at least on that Evo 10. So I'm an electrical engineer by training, didn't want to be stumped by that, so I ordered up an oscilloscope so we can take a look at what Warn's doing with that. I'm not sure this is going to work. Let's head down to the garage, see what we can find out. Before we head into the garage, I want to make a quick note about why I'm having difficulty with this. So this is a typical winch setup where you've got your controller, you've got a cable, and then a solenoid on the winch itself. And the controller just has these switches on it that connect the relays to power. And this is what I was expecting, and I tried doing my own switches, and it wasn't working. So we're going to make some measurements in the garage to figure out what is happening inside this Warn Evo winch controller. Alright, welcome to the workshop. I've let my brain juice cool down a little bit, and I've been getting everything set up. Got some interesting measurements. So let me go through the setup here real quick. So I've got an oscilloscope with 2 channels here. The 2 channels are leading to the 2 what seem to be signal wires on the remote. The remote's wired into the winch on the inside of the forerunner. And then I've got some wiretaps set up in here so that we can get the signals on the screen. So this is an oscilloscope. You can kind of imagine it like a multimeter that measures voltage over time, then displays the voltage on the y-axis and time on the x-axis. We kind of scroll through here. This is like time passing by. And our scale is pretty small here. We're in like the milliseconds. What I'm seeing here is kind of a pattern of long, long, short, short, short. This is for spooling out. And then on spooling in, it was short, short, long, long, short. I'm not really sure why Warren chose to do this. I think it's probably safety related. You can imagine if your signal wire is routed and chafing, and maybe one of the signal wires gets shorted to power in like an old regime with traditional winches, that could cause the drum to start spooling uncontrollably. Whereas this, if you've got some kind of a signal, a short isn't going to turn on the winch. Unfortunately for us, that means that we've got to have something smart that can send out these pulses, and we can't just, flip a switch. And maybe you saw the blue line on the oscilloscope where it kind of droops and fades slowly over time. I don't even know if the blue line is used, so I'm going to try disconnecting it and see if the remote can still control the winch. So this is with the blue channel disconnected. Will the winch run? Yeah, so it seems like the winch will run without it. Warren, got any engineers who want to let me know what decisions led to this regime? Kind of interesting. So what we've established is there's some kind of smart brain on the controller side that creates these digital pulses that get sent out and interpreted by some kind of brain on the winch side that then controls the motors. And we've also determined that there's one of these signal lines isn't used. And then finally, we're still trying to figure out how these switches interface with the brain, so we're going to keep digging. I'll just send you through some of the tools that I'm using here. So these are called posi taps. These are little like plastic tubes that have a conductor inside, and they allow you to attach two wires. You can see that there's like a wire that comes into the cap and then screws into this connection here. So it's meant to be robust enough to disconnect and reconnect multiple times. If I'm doing some prototyping with wiring inside or outside of the car, these are kind of nice to get things hooked up, and then later you can do like a crimp on them for a more permanent connection. But it's nice that you can disconnect these, like we just wanted to disconnect that one line and see if we could still get signal, and it still worked. And then the other connection on here, these blue things, these are also posi taps, but these ones are actually tapping into the wire. In order to get my oscilloscope probe hooked up to this, there wasn't like a great place to probe on it, so ran a posi tap into the wire and then was able to run out a signal lead here. I think I'm going to use this brain for a brain transplant for our in-cab controls. Now I'm going to use my multimeter. I've got it in conductivity mode, so whenever there's good conductivity between the two probes, we get a beep. So I'm just looking at these switches and trying to figure out, do they conduct across horizontally, which is my suspicion. Maybe not. Or do they conduct this way? So now when we push the button, it should beep. Might be a little bit tough to see here, but there are 4 pads on the switch. And so these top 2 are the same node, and the bottom 2 are the same signal. So you can imagine these 2 pads as 1 pad. And then when you push the button connects the top to the bottom. And then for this measurement, I want to measure what's actually going across the switch. So let's take a look. Let's see what we've got. So this is the lower pad on the switch, and it seems to have a pull-up resistor, a pretty weak pull-up resistor, and then when you push the button, it grounds it. So you can see on the screen back there maybe. I'm going to push the button, and the signal drops. And then same kind of story on the bottom switch, the retract winch switch. Let's see, so it's being pulled high normally, close the switch, and it gets pulled down. So I wanted to do a little visualization of what I was talking about with the pull-up resistor. That might be kind of an odd term for a lot of folks out there. This might be what you would expect for a button that closes a switch and then switches the input from low to high. This is kind of like if you have a light switch wired in your house, It just opens and closes a circuit. We don't use this as much in like embedded electronics, because like if you close this switch and then open it again, then the charge can just stay on this input. There's nowhere for the charge to go. So what we usually do is this scheme over here where you've got a resistor pulling up the input normally, and then when you hit the button, it will connect the input to ground. So this prevents the case where you've got a floating input, and then it's also nice if you have like one chip talking to another chip and the two chips are on different voltages, that it's just easy to get the right input drive voltage by using a pull-up.
Ignore all the controller stuff in the background. This is the switch that I've got for the winch. So you can see in and out. On the bag for this, let's see if we can read it. Yeah, so green and orange are clearly the outputs, and red is labeled as 12 volts plus. But really, the red is just the input for the switch. Whatever you want put on those outputs, you put on the red. So basically the switch is just connecting red and green and orange on the inside. Again, I've got my multimeter in conductivity mode, and I've got my wires hooked up to green and red right there. Green should be out. So when we push out, we get conductivity. All right, then just to prove it, that we know what we're talking about, orange should be in. There we go. For our design where we want to pull down the pin, we're going to connect what's labeled as 12 volt on here, the red wire, to ground. So for this little proof of concept here, we're going to solder the wires directly to the same pads that the switches are already hooked to. So here are our original switches that were on the controller brain board, and we've got our little pull-up resistors represented here. So when you close the switch, the inputs would get pulled down. And so what we're doing is we're going to piggyback these switches on the toggle straight onto these solder pads, so that instead of pressing these on-board buttons, we can use our toggle switches to pull that input down to ground. Okay, don't sneeze. Let's do this other guy. Soldering's done. I'm going to plug in our winch connection. So I'm connecting the input to ground. So we're ready for a little bit of proof of concept here. So we know that these buttons work. And we have our switches, the outputs connected to pulling down the inputs on what must be a microcontroller. And then our input is the system ground. So proof of concept works. I'm not in love with how thick these wires are connecting to little teeny tiny pads on these buttons. I think that's going to be it for this session. I'm going to try working up like a little 3D printed enclosure for this thing that I can have a little connector going into that's more robust and is going to last 30 years, not 30 minutes. I catted up this little representation of the PCB, the little controller brain. This guy that's coming from inside the controller. Now we can build an enclosure around it. All right, now we got a little box enclosure. There's some screw bosses in the four corners with the screw holes that are already in the PCB. And then this chunk taken out over here to make clearance for the wire connector that goes in. Now we can make a lid. And here's a shot of our lid. You can see I drilled some holes so we can see the LEDs. And then, let's see, I've got this kind of stopper that comes down onto the wire connector over here. So yeah, I'll try to print this up, see what happens.
This is a resin 3D printer. It works by dipping a build plate into a vat of resin and then using UV light to cure a layer, and just does that over and over and over.
Let's see what we got. Yep, looks like this one turned out.
It's a little bit more involved than like the filament-based 3D printing. You've got to cut off your supports, then wash off any excess resin in an alcohol bath, and then you've got to bake everything in a UV exposure oven kind of thing. So here's the UV curing process.
There's our little enclosure. Some of the sides are a little bit less aesthetic than others. There it is. It all fit in there. Measured right. That's a good feeling. And it feels pretty cool to have a little custom enclosure. I mean, look at that. I just inserted that little JST connector with these leads on it, and it's a press fit. Like, I don't think I even need to glue it in there. That's pretty awesome. There's the enclosure with, these will be our in and out signals from the switch. And then here's the signals that will go to the winch. Yeah, that feels pretty tidy. We're doing some final checks here before we start installation. We've got our little brain box, which my LED cutout is working perfectly. And then we're hooked up to the worn cable again and go into the winch. And then we've got our wires hooked up to the switch. Got my red input wire hooked up. Awesome. Yeah, I think now the last thing that I want to do is take some epoxy and really secure these wires in. So like right now they're just held on with the solder, which is not ideal from a mechanical perspective. For longevity's sake, I'm going to glue those wires down. Say goodbye to the board. This will be the last time that we can see it. Sealing it up for all eternity. It's like King Tut's tomb. I'm starting to wire up the switch inside the cab, and there were a couple points that I wanted to share. One decision that I made was that I wanted to put the switch on the ignition 12 volt. That way if the key's not in the car, the winch won't operate. Then the other thing that I wanted to share was you saw me prototyping with these little posi taps to tap into a wire, and I'm going to use these again to tap into like the 12 volt and the illumination wires inside the cab. These are just so much better than any of the little like crimp or any of the other styles. These are a couple bucks a piece and they are just so worth it. Save yourself the time and headache and just use these posi taps. I know it's kind of a mess, but these are my existing switch connections, and you can see the brain in here that we built. And I was just going to do a quick sanity check, turning on the 12 volt ignition, make sure everything's wired up correctly so far. Yep. So there's our red LED lighting up. So far so good. Doing another sanity check real quick. You can see the oscilloscope. I hit the button, it should send our pulses. Maybe you saw my heart sink when I tried to hit the button and it didn't work last time. Pretty disappointed. Yeah, that's a tough feeling. Luckily, since I used those posi taps, I was able to unscrew it, take the whole unit back over to the bench, and it took like no time at all to take it out. So I took the whole setup over to the bench, and I was kind of replaying this old wisdom that a technical program manager of mine used to say. He'd always ask, what changed? If anything went wrong, what changed? And so I was trying to think back, and I was like, well, I guess I didn't test it after the epoxy dried. Maybe like a short formed while it was drying. So I was like picking up the epoxy and like trying to look at where a short could be, wasn't finding anything. And then I realized that I was grounding the switch, which, did I do that before? No, I don't think I was using the ground wire before. And it turns out that there's little diodes on that switch that light up when the switch is in the on position. And so the diodes were providing a path to ground that wasn't there before. So I'm not going to use the ground, and I'm not going to have those LEDs that light up, but everything should work. So I'm going to get my honest reaction here. I don't know if you can see the oscilloscope in the background. But we have signal. Whew. Yeah, let's keep going with the install. And then just one more thing. While I was in there, I ran a bunch of this, I think it's called Tessa tape or wiring harness tape, kind of a cloth tape that helps reduce rattles. Back around the front of the truck, I took that worn winch cable that used to have the 4
wires, and all we're using out of there is that white wire anymore. So put a little spade connector on there, and I'd actually already run a spare wire through the firewall. So we're going to plug that up, and we should be able to control the winch. It worked! So that's a wrap on that project. It's kind of fun to get the oscilloscope out, see what's actually going on with the signals and why just applying voltage wasn't working. And then kind of fun to do some 3D modeling and build that little enclosure and actually get this to work. Let me know if you have any questions. I'm going to get this cleaned up and I'll see you in the next one.